What's up, guys? In this video, what I want to do is help you understand how to add and subtract fractions when we have uncommon denominators. Now, we're going to go ahead and do that by working through 5 different examples to help you out through the process. I hope you enjoy.
What we're going to do is show you fractions when we have unlike denominators. So for this problem, what I'm going to do is, check that out. Ooh, okay. When I'm going to be taking a look at this, remember when we're adding or subtracting, we always have to make sure we have the common denominators. So in this case, I noticed that my common denominator is 6. So the first thing I need to do, actually, let me first actually show you what 1/6 would be. Remember, one section of these, and 2/3 is going to look something like this. Okay? So what I'm doing is, if I have 1/6 minus 2/3, I got to first make them into equivalent fractions. So I'm going to change this to be a 6, so therefore my denominators will be the same. I make sure that whenever I multiply my denominator by a number, I need to multiply my number, or my numerator. So therefore I'll have 1/6 minus 4/6. Now, just like adding and subtracting, remember, whenever we're subtracting or adding, remember, you keep the denominator the same and you just add and subtract the numerator. So 1 borrowing 4, or 1 minus 4, is going to give me a negative 3/6. So how do you represent that up here? Well, I drew kind of not really good colors, but really, if I was to draw this into sixths, this right now currently into thirds, so into 6, I'd cut each one of these in half. All right, and you can see that, obviously my 4/6 is the same thing as 2/3. So what happens is, if I have 1 and I need to subtract, though, 1, 2, 3, 4, I'm really going to be missing. These are like going to be my negative, right? This is what I'm still going to owe. I'm still going to owe these 3 bars. So 1 minus 4, I'm still going to owe a whole 3 more bars. That's why we have the sign is negative. So it's a negative 3/6. Let's just take a look at another example. Let's say I want to subtract 2/7 minus 5/14. So again, in this case, what we notice is our denominators share one of our denominators, our common multiple shares one of our denominators. So therefore, the common multiple between 7 and 14, or the common denominator, is just going to be 14. So really simply, to get these to be there, actually, I made a mistake here. Let's do, no, yeah, that's okay. So what I'll do is I'll multiply by 2/2. So therefore, now I'll get 4/14 minus 5/14. Numerators are the same, subtract, denominators are the same, subtract the numerator. 4 minus 5 is going to give me a negative 1/14. And that's your final answer. Oops, here, I forgot. Let's go and reduce this. Negative 3/6 can be reduced by 3 on the top and bottom to a negative 1/2. All right, ladies and gentlemen, that's your fractions of subtracting with unlike denominators. Remember, when we're going to be adding or subtracting, we got to make sure we have our common denominator. And to find common denominator, what we're going to do is we need to find a common multiple that our denominators share. So one of the easier tricks to kind of look at is, just to write out the multiples of each of your denominators. So if I was going to start it with 4, well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. Then if I list the multiples of 3, I get 3, 6, 9, 12, and I'll stop right there. As you can see that they share a common multiple, 12. So what that means is 4 and 3 both go into my multiple 12. So what I need to do is figure out, well, I need to get them both to 12. So I need to figure out, what do I need to multiply 4 by to get to 12? Well, the answer is 3. And what do I need to multiply 3 by to get to 12? Well, that answer is going to be 4. Now remember, since we're dealing with fractions, we want to keep these equivalent fractions. So what I'm going to do is, I need to make sure I multiply the numerator and the denominator by 3 and 4. So now what I'll do is, I just simply multiply across. 3 times 3 is going to give me 9, and 3 times 4 is going to be 12. 1 times 4 is going to give me 4, and 3 times 4 is going to give me 12. So now what you guys can see is, now I can simply add up my answer, and what I'll end up getting is 13/12. Now, so that's one way to find your equivalent multiple. That's one tip. Another way to look at it is to simply just say, well, what you guys noticed up here is all I did was multiply my one denominator by the other denominator, right? And a lot of times that's going to work. So you can do that for this problem. Let's just skip the chase and let's just multiply by the other multiple or the other denominator. So I'll multiply this by 6 over 6. In this problem, I'll multiply by 4 over 4. And that kind of gets away of a lot of the guesswork that I'm going to have to do. So therefore, I'll be left with 18 over 24 plus 5 times 4 is 20 over 24. Add those two up, I get 38 over 24. Now I'll get to the reducing this down in a second, but what you notice is since these are both even numbers, I can reduce it. But I wanted to show you a quick little way. A lot of times this works, but however, this isn't always the quickest way because if you notice, I now have to reduce my ending fraction. So that's why it's always important to find the lowest common multiple. And the lowest common multiple is not 24, but it's actually 12, as 4 and 6 both go into 12. So to get into 12, I need to multiply this by 3 over 3. And to get 6 to be 12, I need to multiply by 2 over 2. Therefore, when doing this, I now get 9 over 12 plus 10 over 12, which equals 19 over 12, which, if I were to reduce this by dividing it by 2 on the top and bottom, I would get 19 twelfths. So just be careful. Even though this works for all of them, you want to find your lowest common multiple. Therefore, you already have your reducing done for you.
Welcome, everybody. It's Mr. Bigums back again. So I'm here in this school, and I came in here to go and get on a whiteboard so I can show you how to subtract fractions. Now, I don't know where I'm going to be next, so I'm going to try to get this done as quickly as possible, hopefully give you an overview of fractions, because then I got to get out of here before they catch me. I might be in a new classroom tomorrow, and I might be in a classroom with yours next week, so stay tuned. Listen up here so you can make sure you understand what I'm going over. So I want to show you how to subtract fractions. Now, the first thing we need to know when we're talking about fractions is, what is a fraction? Well, pretty much, if you have something whole, and I always like to think of a candy bar because I'm always hungry. All right. If I think of a candy bar and I divide up that candy bar, let's say I have 4 friends or 3 friends, including me, that I want to divide up. So therefore, I'm going to divide it into 4 different pieces. So if I divide that into it, what I've just created is some parts out of a whole. So if a whole candy bar is divided into four different parts, I have 4 parts over a whole. Now, let's say I want to keep. Let's say I want to keep 3 of those parts, and I only want to give 1 of those 4 parts to a friend. So therefore, I've given away 1/4, and now what I have is 3 parts out of the whole. So you could say I have 3/4. Now, in a fraction, we divide how many parts we have, or we're dealing with, over the whole by what we call a fraction bar. So let's say I have 3/4, okay? I have 3/4 of the candy bar because what I did was I gave away 1/4 to my friend. Now let's say this girl friend over here wants a piece of my candy bar as well. So I decide to give her 1/4 of my candy bar. So if I already have 3/4 and I subtract 1 more 4th, how much is left for me? Let's take a look. So I said I had 3/4 of a candy bar. I'm going to subtract, I already gave away 1 to my friend Fred. But now Jessica over here, I want to give her a part. So I'm going to say 3/4 minus 1/4. How much am I left with? So if I take these 3 sections, subtract 1 more, I'm left with 2/4. So therefore, I'm left with 2 more pieces out of 4 in my candy bar. Now, one thing we got to make sure is whenever we're talking about fractions, we always want to put our fractions in lowest terms. Meaning, can these 2 numbers, my top number, which we call our numerator, and our bottom number, which we call our denominator, can they be divided by the same number? And you can say, yes, 2 can go into 2 and 2 can go into 4. Therefore, if I'll divide the top and bottom number by the same number to get it into lowest terms. So 2 divided by 2 is 1, and 4 divided by 2 is 2. And you guys should know that 2 out of 4 is 1/2. All right, so you just always want to make sure we put it in the lowest terms. So that's the general idea. Now, let's go ahead and work on some extra problems. Okay. So the first one, we have 5/10 minus 3/10. When you're subtracting fractions, we have to make sure that our denominators are the same. And what we're going to do is just simply subtract the numerators. So 5 minus 3 is 2 over 10 parts. Therefore, now I can reduce this again. 2 is a common denominator for both these, so I can divide the top and bottom by 2 to receive 1/5. Now,
let's say we have a problem. Let's say that I now have, oh, I need to subtract. Let's say now I have 3/4 of a candy bar, and I want to subtract 1/3 of another candy bar. How much parts of a candy bar am I going to have left? Now, it's easy when you have the denominators that are the same, because you can just subtract the numerators. However, think about it this way, ladies and gentlemen. If I am to subtract 3/4 of a candy bar and subtract 1/3 of a candy bar, well, my new candy bar, or the new amount that I'm going to have, if I have 3/4, and look, I try to subtract this amount, which roughly relates over here to this amount, I'm left with, looks like 1/4 plus another little extra part left over. So I don't really know what that value is. So what I need to do is I need to segment my new candy bar into a measuring point that fits for both 3/4 and 1/3. And that the way we find that measuring point is finding what we call the LCM, or the least common multiple. So I need to find the least common multiple for my two fractions. So I look at 3 and 4, and I say, all right, what multiples do these two numbers share? Well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. Over for the 3's, I have 3, 6, 9, 12, and 15. And what you notice is the smallest number that they share is 12. So what I can do is I can now break up my new fraction, or my result, into 12s. Okay, now I know this is not going to be even, but what you could say is, well, how many 12s is 1/3? And you could say, well, that's going to be 4 of them, right? And then how many 12s is going to be 3/4? Well, let's look at it. To get this to be 12, I need to multiply by 3 over 3. So therefore I have 9 12s minus, to get this to be 12, I need to multiply by 4 and over 4. So I'll have 4 12s. So 9 12s, which would be this much. So this is equal to 9 12s minus 4 12s is going to equal how many 12s? Well, 9 minus 4 is 5 12s. So therefore, 1, 2, 3, 4, 5. So you could say if I have this many 12s minus 4 12s, or 9 12s minus 4 12s, is going to leave me with 5 more 12s. Let's look at one more example. When I don't have the same denominator, I need to find the common multiple. 5 and 7, let's say I have 5, 10, 15, 20, 25, 30, 35, 40, and 7, I have 7, 14, 21, 28, 35, 42. Now sometimes, guys, this can take a long time. It's not always the quickest or the easiest, but sometimes it might be easy to multiply them across, or just multiply your two denominators to find a multiple. It's not always going to be the least common multiple, but it will always give you a multiple. So to get to 5 to 35, which is the smallest, not 38, 35. To get to that to be the smallest, I'll multiply times 7 on the top and the bottom. And here, to get this to be 35 on the bottom, I need to multiply 7 times 5. 7 times 2 is 14, over 7 times 5 is 35, minus 4 times 5 is 20, over 35. So therefore, if I have 14 parts, and now I give away 20 parts, I have a -6 over 35. So what that means is it's a negative fraction, meaning I actually owe more parts than I really would have. So you can have a positive number minus a negative fraction that is bigger or more than the other fraction will result in a negative fraction.
The main important thing, if you guys remember when we were dealing with fractions, was when we're adding and subtracting fractions with unlike denominators, we have to get common denominator. So the first thing we have to do is what we determine is called determine the LCD. Find the common denominator of 5 and 6. And what that means is the smallest number that 5 and 6 divide into. Okay? So does anybody want to raise their hand and see what the LCD of 5 and 6 is? Ooh. Huh? 30. Very good. So if it's 30, what we want to do is we want to be able to multiply. Brandon, what are you doing? Okay. What we want to do is be able to multiply our denominators so they're both going to be 30. So on the left side, I'm going to have to multiply by 6. On the right side, I'm going to have to multiply by 5. All right? But please be careful, ladies and gentlemen. When we are multiplying a fraction, if I just multiply the denominator, I'm going to change the value of the fraction. So I have to make sure I multiply the denominator and the numerator by the same value. That's going to produce equivalent fractions. So therefore, now I have 18 over 30 plus 10 over 30. Everybody follow me? Mm-hmm. OK. So now I can simply just add them up. 28 over 30.
All right, ladies and gentlemen, what I want to do is go over another example of fractions adding when you have unlike denominators. So here I'm going to have 2/5 plus 2/3. Now remember what I showed up here. When you have your when you have your fractions and they're not divided by the same term, so here's divided by 2 and this one bar was divided by 3, I can't just simply add them and say that's, because think about it, if you add the numerators, right, I'd have 1 plus 1, that's going to give me 2. Well, what is that? Is that 2 halves? No, because 2 halves would make 1. Is that going to be 2/3? No, because look at 2/3 only goes up here. It doesn't get to as high as what actually your answer is going to be. So what we need to do is make sure we have our common denominators. So to get 5 and 3 to be my common denominators, I'm just going to want to list the multiples of each number. So to list the multiples of 5, I can do 5, 10, 15, 20, 25. And I'll stop there and just try check 3 and see where I'm at. 3, 6, 9, 12, 15, 18. So what you notice is that 15 is going to be my common multiple. So what that means is my answer, I'm going to want to get 15 plus 15. So now what I got to do is got to determine how am I going to get 3 and 5 to be 15. Well, to get 3 to be 15, I need to multiply by 5. And remember, whenever you multiply your denominator by 5, to keep an equivalent fraction, you're going to have to multiply the numerator. So to get 5 to be 15, I need to multiply by 3. And I multiply on the top and the bottom. So 3 times 5 we know is 15. 3 times 2 is going to be 6. 5 times 2 is going to be 10. Now all I can simply do is add 6 plus 10, which is going to give me 16 over 15. And that is going to be an improper fraction, but that's okay. And I'm just going to leave that as my answer. So once again, ladies and gentlemen, that is how you add fractions when you have unlike denominators. Please, please do not just simply add them up and say, give me 2 parts, and then try to pick a denominator. You have to find the common denominator by taking the multiples and seeing which multiple they share in common, and then multiplying to get that multiple. All right, there you go, ladies and gentlemen.